this section, we'll explore the main network architectures that define how devices and infrastructure are organized. You'll learn about two-tier and three-tier designs used in enterprise LANs, the modern spine leaf model for data centers, wide-area networks that connect sites across distances, small office and home office setups, and the differences between on-premises and cloud networking. Understanding these architectures will help you see not only how networks are structured, but also why different designs are chosen for different environments. The two-tier architecture is a simplified network design made up of the access layer, where end devices connect, and the distribution layer, which aggregates those connections. Its purpose is to provide a straightforward, cost-effective way to structure small to medium-sized networks. This design is easy to manage and deploy, requiring fewer devices and less complexity. Key features include VLAN segmentation, policy enforcement at the distribution layer, and simple inter-VLAN routing if distribution switches operate at layer 3. It is less scalable than larger models, but ideal for environments where growth is limited. In operation, the two-tier design connects users through access switches and forwards aggregated traffic to the distribution layer for policy decisions and routing. Common use cases include branch offices, schools, and mid-size enterprises, where simplicity, lower cost, and easier management outweigh the need for high scalability. The three-tier architecture builds on the two-tier model by adding a core layer on top of access and distribution. Its purpose is to provide scalability, resilience, and high-speed connectivity for large enterprise networks. This model is modular and fault-tolerant. The access layer connects devices. The distribution layer aggregates and enforces policy, and the core acts as a high-speed backbone. Key features include redundancy, load balancing, and support for very large numbers of devices. In practice, the three-tier model separates local access traffic from backbone traffic, ensuring performance and fault isolation. It is widely used in corporate headquarters, university campuses, and large enterprises where growth, high availability, and performance are critical. Spine leaf is a modern data center design where every leaf switch connects to every spine switch. Its purpose is to provide predictable, low-latency paths for workloads that generate heavy server-to-server communication. The design is highly scalable and balances traffic evenly across the spines. Each device has the same number of hops to reach another, which guarantees consistent latency. Key features include modular growth, horizontal scalability, and optimization for east-west traffic. SpineLeaf provides large data centers with fast, balanced communication between servers and applications. Use cases include cloud providers, virtualization-heavy enterprises, and environments that demand predictable performance for distributed workloads. A wide area network, or WAN, connects multiple LANs across geographic distances. Its purpose is to enable secure communication between branch offices, headquarters, data centers, and the cloud. WANs rely on service providers and technologies such as MPLS, leased lines, or site-to-site VPNs. They are more expensive than LANs, can introduce latency, and require careful planning. Key features include redundancy, secure tunneling, and connectivity across cities or even countries. In operation, WANs extend enterprise connectivity globally and provide secure inter-site communication. Use cases include retail chains connecting branches to HQ, enterprises accessing cloud applications, and organizations setting up disaster recovery sites. SOHO networks are designed for small offices or home users, providing basic connectivity at low cost. Their purpose is to give users reliable access to the internet and local resources with minimal complexity. These networks usually run on consumer or small business equipment, often a single, all-in-one device combining routing, switching, Wi-Fi, and firewall functions. They are cost-effective, simple to configure, but limited in scalability and advanced features. SOHO networks provide wired and wireless connectivity, basic firewall protection, and NAT for internet access. Common use cases include remote workers, startups, and small branch offices where ease of use is more important than enterprise-grade scalability. On-premises networking means infrastructure is hosted and managed locally, while cloud networking relies on provider-managed resources. The purpose is to give organizations flexibility in where and how services are deployed. On-premises offers full control and data sovereignty, but requires higher capital investment. Cloud provides scalability, agility, and reduced management overhead, but depends on internet connectivity and provider trust. Hybrid models combine both for balance. On-premises suits compliance-heavy industries like banking or government. Cloud fits startups, SaaS applications, or organizations needing rapid scaling. Hybrid environments are now the most common, blending control with flexibility for modern enterprises. We've now looked at the characteristics, features, and use cases of two-tier, three-tier, spine leaf, wide area network, SOHO, and on-premises versus cloud designs. Each has its strengths and trade-offs, from simplicity to scalability, from cost-effectiveness to performance. Before moving on, review the slides and take the quiz available on the website to reinforce your understanding. Once you're confident, you'll be ready to continue to the next section, where we examine physical interface and cabling types and see how the medium itself shapes network design.